Hello, good day to one and all. I am T. Ramesh, Assistant Professor from Department of Electrical and Electronics Engineering, Mahindra College of Engineering. So in this video, I am going to take about signal flow graph in control system. So basically, signal means a physical quantity that carries information. So that is called as a signal. So here the signal flow graph means it is a diagram that represents how the signal flows from one point to another point and also give the relationship among the signals. So also it is a diagram that represents a set of simultaneous algebraic equations. By taking Laplace transform, the time domain differential equations governing a control system can be transferred to a set of algebraic equations in S domain. By using these equations in the S domain, we can construct the signal flow graph. Okay. So the signal flow graph consists of node, branch, input node, output node. So these are the some terms used in signal flow graph to construct the signal flow graph. Okay, we go directly to the formula. That is the formula used to find the transfer function of the system. Okay, so the transfer function of the system can be obtained by using the Mason's gain formula. So this formula is given by T equal to 1 by del epsilon k pk into del k. Here k is number of forward paths in the signal flow graph. Pk means forward path gain of kth forward path. Okay, we can understand what is pk and k by solving the problem. Okay, so the main advantage of the signal flow graph is the overall gain can be easily calculated compared to some other methods, that is the block diagram reduction method, like that. Okay, now here the terms used pk and del k. So what is del and what is the how del k? Okay, we are going to see what is del and del k. So del is given by 1 minus sum of individual loop gains plus sum of gain products of all possible combination of two non-touching loops minus sum of gain products of all possible combination of three non-touching loops plus etc. It is going on. Okay, so del equal to 1 minus sum of individual loop gains plus sum of combination of two non-touching loops minus, so this plus minus repeatedly changed. Okay, then del k is delta for that part of the graph which is not touching kth forward path. We can understand what is del k by solving the problem. Okay, here one problem is given. They are asked to find the overall gain C of s by R of s for the signal flow graph. Okay, so here R of s is the input and C of s is the output. We are going to find the overall gain, that is the transfer function of the system. So here 1, 2, 3, 4, 5, these are all called as the nodes. Okay, the nodes means they are representing the variable or signal, and the first step to solve this problem is to find the number of forward paths. For every signal flow graph, first the step is we have to find the number of forward paths. So here the signal flows always in one direction only. Only one direction only. Okay, so here the signal starts from one node, from the node 1, 2, 3, 4 and 5. From R of S to C of S, it reaches 1, 2, 3, 4 and 5. This is one direction, one forward path. The next forward path will be 1 to 2, 2 to 3, 3 to 5. Okay, this is the another forward path. Okay, we see in the next slide. So this is the first forward path, that is the signal starts from 1 and it goes to 2, 3, 4 and finally it reaches 5. Okay, this is the first forward path. And also here the given system has two forward paths, therefore the letter K, that is used to represent the number of forward paths. Okay, so in the given system it has two forward paths, therefore K equal to 2. So this is the first forward path. The gain of the first forward path we represent P1, the letter P1. So P is 1. So here the gain is the combination of all gains G1, G2, G3, G4. So this is the gain of first forward path. So this is the second forward path, that is the signal travels from 1 to 2, 2 to 3, 3 to 5 and it does not flow on through the node 4. Okay, so here the gain is, it represents the letter P2. So second forward path, so it is P2. So it is the product of gains given in the problem, that is G1, G2 and G6. So this is the gain of second forward path. Okay, so the next step is, the second step is to find the individual loop. So before going to this, we should know what is meant by loop. So loop means a signal starts and ends at the same point, same node, that is called as the loop. So here the given system has 5 loops. The first loop is the signal starts from 2 to 3 and 3 to 4 and it ends at the 2, the starting point. So here G2, G3 are the gains and H1, that is the feedback of the first forward path, first loop. The second loop is the signal travels from 2 to 3 and again it ends at the node 2. So its gain is given by P21, that is minus G2H2, that is the product of gain and the feedback value, that is H2. And the third individual loop is that signal travels from 2 to 3, 3 to 5, then it ends at the node 2. So the individual loop gain of this loop is P31. We take P31, that is the product of gain and feedback, that is minus G2, G6 and H3. Okay, so the fourth individual loop is 2 to, it travels 2 to 3, 3 to 4, 4 to 5 and again it ends at node 2. Okay, so here its gain we taken as P41, that is the product of G2, G3, G4 and the feedback, that is H3. So minus G2, G3, G4, H3. And the fifth individual loop is P51, that is the loop starts and ends at the same node. So that is the loop 5. Its gain is G5. Okay, so the first step is to find the number of forward paths. The second step is to find the individual loop gains. So in the given system it has 5 individual loops and we have write the 5 individual loop gains, P11, P21, P31, P41 and P51. Okay, then the next step is to find the non-touching loops. So here first we are going to find 2 non-touching loops, the loops which do not touch each other, that is called as the non-touching loop. Here 2 combination of non-touching loops are present in this problem. So the first combination of 2 non-touching loop is that is taken as P12, that is the product of P21 and P51. So we have already seen in the previous section, that is P21 and P51. These 2 loops are not touching with each other. So this is the first combination of non-touching loops. So its gain will represent as P12. So we represent the gain product of two non-touching loop is P12. So this is the product of the gain of the individual loops, two loops. So that gives G2, G5 and H2. The second combination of two non-touching loop is that is given by P22. That is the gain product of P31 and P51. These two loops are not touching with each other. So its gain will be the product of gain of the two individual loops, that is the P31 and P51. Therefore we get minus G2, G5, G6 and H3. So why here the gain of P51 is only G5. So the product of P31, P51, it will be minus G2, G5, G6 and H3. Okay, so this is the gain of two non-touching loops. So the next step is calculation of del and del K. So how to calculate del and del K? So here del is given by 1 minus the sum of individual loops. That is here we having 5 individual loops. That is P11, P21, P31, P41, P51. We have summing, we have adding all the 5 individual loop gains plus the possible combination of two non-touching loops. Here we have two combination of two non-touching loops, and also the next step will be minus 3 combination of non-touching loops. Here we have only combination of two non-touching loops. The 3 non-touching loops are not present here. So substitute the values 1 minus P11 value, P21 value and P31, P41 and P51, and we have already calculated in the previous step the combination of two non-touching loops, two combinations P12 and P22. Substitute every values. Okay, then calculation of here we have K value is 2. Okay, K value is 2. Therefore first take the first forward path. In the first forward path there is no part of the graph which is not touching with the first forward. That means all the parts of the graph are touching with the first forward path. Therefore del 1 may be equal to the value of del 1 is 1. Why we are going to calculate del 1 and del 2 means K value is K value is 2. So we have to calculate del 1 and del 2. So how to calculate del 1 means take the first forward path. In the first forward path all the parts of the graph are touching with the first forward path. Therefore we have take the value of del 1 equal to 1. Okay, next to find del 2. How to find the del 2 means take the second forward path. In second forward path the part of the graph which is not touching with the second forward path is the loop 5, that is G5. So therefore we have to find the value of del 2 equal to 1 minus G5. So how to find del 2 means take the second forward path, the part of the graph which is not touching with the second forward path means that the last individual loop gain G5, that is not touching with the second forward path. So del 2 equal to 1 minus G5, the gain of the fifth individual loop. Delta 2 equal to 1 minus G5. Okay. Then the final step we are going to find the transfer function of the system. So transfer function of the system or overall gain of the system. How to find the overall gain of the system is by using the Mason's gain formula. So this Mason's gain formula is given by T equal to 1 by del epsilon K Pk. So here the value of K is 2. Therefore we have to find P1, P2 and del 1, del 2. So this can be written as 1 by del the summation of epsilon K Pk, that is P1 del 1 plus P2 del 2. P1 means that is the gain of the first forward path, P2 means gain of the second forward path. That is we have already found in the first step. By substituting these values and simplifying, we can get the overall transfer function of the given signal flow graph. Okay, so once again I repeat,